Tell me, do you know EDM? EDM stands for Economic Traffic Management, and it is an approach to manage and control internet traffic as internet service providers by economic mechanisms. Let's give you some details. Utility functions are used to find an optimal resource allocation while maximizing the utilization of this resource. Here is an example. The bandwidth of a network affects the file transfer time, and the user's satisfaction decreases with the time a file transfer takes. Thus, users value a certain quality of service over price. But are those utility functions scalable and effective in real life? For instance, by applying ETM on an overlay network in the Internet, ETM leads to an incentivized collaboration between Internet service providers, users, and overlay network providers. This leads typically to provider-independent communication between users. But millions of those users cannot and do not want to tell providers their application-specific utility functions. The result? Utility functions are not scalable and raise many privacy concerns additionally. Thus, an applicable management approach in practice is needed. EDM defines this approach since it applies measurable incentives to define economic mechanisms. ETM's major targets include for ISPs, monetary ones, reducing overlay traffic and interdomain traffic, performance ones, reaching less congested links, and reputation ones by keeping customers and distinguishing yourselves from other operators. ETM's main targets cover for overlay providers performance. Playing an active role in traffic management increases the service quality, and reputation ones, reaching an increased user base due to better performant services. And finally, ETM's main targets for users comprise of an increased performance and service quality in round-trip times and bandwidth, and monetary ones exist in terms of lower prices for network access. In that sense, is ETM suitable and practically operational? Yes, ETM only requires support for this collaboration, which is optional for all three stakeholders. Let's take a look on the sample network configuration of three networks, which are connected with each other through links with different properties, transit or peering. The EDM support is provided by an EDM information server, either part of each ISP or provided as a third-party service. In case of a file-sharing overlay, these EDM information servers offer ranked lists of resource locations for files. Such data is collected in a decentralized manner and placed into EDM information servers according to ISPs, overlay providers, and users' knowledge. Assuming that EDM information servers have been populated, user Alice is now in search of resource R. R exists in three locations within the overlay. Which resource shall the user access? The resource in ISP-B is only accessible via transit link, thus expensive. But it is also available in ISP-C, accessible via a peering link, which does not incur transit costs, thus being cheaper. However, in the example here, the resource is also available at home, which means that the round-trip time for accessing it will be much lower compared to other locations. Thus, ISP-A determines the preferred location for accessing the resource R. Exactly this user's decision is reflected in those entries ETM information services hold. Scientific evaluations have shown that the ETM information server are populated correctly according to each stakeholder's incentives, and that such a collaboration makes all stakeholders better off if they decide to collaborate. In turn, the EDM approach proves to be applicable and effective. By now, you know the basics of the economic traffic management approach. To find out more about general economic constraints of network and service management tasks, as well as legal and regulatory ones, go to www.fp7-flamingo.eu.